Did you know that China is internationally acclaimed as the infrastructure maniac? This nickname isn't derogatory. It reflects the awe of the international community towards China's infrastructure construction capabilities. China has gained global recognition for its ambitious mega-projects, from constructing highways capable of serving as airplane runways to dams that dwarf even the legendary Noah's Ark. China has pushed the boundaries of construction to astonishing limits. Today, we embark on a journey through China's gargantuan mega-projects. Buckle up for an awe-inspiring ride. While China every day is making amazing progress, achieving real results for technology, infrastructure, improving the nation building and working hard to improve the standard of living for the people, China next door neighbor India on the west border is always busy with their ton of boastful hypes, self-praise on their leadership, chanting superpower, dreaming of replacing China as world manufacturing country, but with not much real achievement, progress and result. For instance, India plans to construct a railway bridge taller than the Eiffel Tower, named the Chenab Railway Bridge. The bridge is designed with a lifespan of 120 years and a height of 359 meters, surpassing the Eiffel Tower by 35 meters. Construction on this bridge began as early as 2002, with the original completion target set for 2009. However, it was abruptly halted in 2008. The project remained at a standstill. In 2010, construction resumed, with Indian media claiming it would be finished by 2016. However, reality proved astonishing. By 2016, only the Bach Bridge pier of the Chenab Railway Bridge had been completed. Full construction resumed in 2017, and due to various reasons, the planned completion was further delayed to 2019. This series of setbacks has led to a prolonged delay in the completion of the Chenab Railway Bridge. Furthermore, India lacked experience and technical expertise in the construction process, resulting in frequent issues and a decline in construction speed. Ultimately, the Grand Bridge took 21 years to complete, and it is expected to be operational by 2024. In summary, although India's Chenab Bridge incorporates high-tech materials and advanced construction techniques, surpassing China's infrastructure prowess remains a formidable challenge. In comparison, China's construction of the Three Gorges Dam, a hydraulic project, has attracted widespread attention and is hailed as an unparalleled feat in hydraulic engineering. Besides, they still have the gut and not ashamed to belittle and criticizing China infrastructures are built like tofu. China's success must have made them very upset, jealous and frustrating that many of their media channels know a day we don't see negative news, fake news and propaganda reports bashing and mocking China like a dog barking at the neighbor daily. But the China just ignored the dog barking noises and keep moving forward to get their business done to achieve what they aim for. Without further ado, let's get straight to the point. Firstly, let's take a look at the super bridge built in China at a cost of nearly 800 million, the Yachi Bridge. This grand bridge stands atop a cliff at an impressive elevation of 434 meters. So, what was the level of difficulty in constructing this bridge? The Yachi Bridge is not only the world's largest continuous rigid frame bridge with a steel-concrete composite deck and a cable-stayed basket handle arch, but also the longest span high-speed railway bridge of its kind. The construction of the main tower's reinforcing steel used a groundbreaking method where steel was bound and formed into shape on the ground before being lifted and installed on the tower columns. The hydraulic climbing formwork employed a system with fewer pole rods, enhancing the appearance and quality of the tower columns' concrete. The connection of the bridge's steel truss arches involved precision welding and bolting, demanding extremely high machining and assembly accuracy, controlled to within millimeters. Any deviation exceeding 2 millimeters could result in misalignment of the bolted joints. The entire bridge required approximately 130,000 cubic meters of concrete, and the steel used in the truss beams amounted to over 16,000 tons. In the gorge where the bridge is situated, instantaneous wind speeds can reach up to force 10. The cable tower's top is 110 floors above the Yachi River surface, posing extremely high construction safety risks. American engineers boldly claimed that China couldn't complete such a project due to its complexity. However, Chinese engineers overcame numerous challenges, successfully completing the Yachi Bridge, showcasing the dominance of Chinese bridge construction technology and marking a significant milestone in the development of the Chengdu-Guiyang high-speed railway. Let's continue to explore one of the ongoing epic engineering projects in China, the Pingla Grand Canal. The canal starts at the mouth of the Shajing River in the West Jinsei Reservoir, spanning approximately 135 kilometers in total length. The overall route of the project is divided into 4 sections: Shaping River Section, Watershed Ridge Section, Qingzhou Mainstream Section, and Estuary Section. Among these, the Watershed Ridge section requires manual excavation. The waterway is constructed to a first-class standard for inland water navigation, allowing for the passage of 5,000-ton inland vessels. Upon completion, this project will significantly shorten the maritime route for goods from the southwest region of China by over 560 kilometers compared to exiting through Guangzhou. This new canal, resembling a soaring dragon, is a crucial component of the West Land Sea New Channel and marks the first inland canal since the establishment of the People's Republic of China. To construct this supersized canal, the Chinese government has invested a staggering 72.7 billion yuan. In the process, Chinese engineers are tasked with excavating approximately 329 million cubic meters of earth and rock, a quantity 3 times that of the Three Gorges project. The excavated materials will be utilized for purposes such as land reclamation, ecological restoration, and infrastructure development, contributing to China's sustainable development. The Pingla Grand Canal can be described as a monumental canal construction project. Once completed, the canal will not only facilitate navigation but also serve functions such as water supply, irrigation, flood prevention, and improvement of the water's ecological environment. Throughout history, the Chinese people have never shied away from challenges. Millennia ago, in an era with underdeveloped construction technology, China built the Great Wall, a wonder of the world. In modern times, despite being besieged by Western powers, China successfully constructed the Jingjiang Railway and the Qiantang River Bridge. These remarkable feats remind us that if miracles had a color, it would undoubtedly be Chinese red. It is understood that the Pingla Grand Canal is expected to be completed and navigable by the year 2027. By then, we will witness firsthand this magnificent new marvel in the history of Chinese infrastructure development.